Solving 6b, review 1 and 2, solving linear equations with lots of fractions in them. Let's get started. Number 1, x minus 17 equals 1. I want to solve for x, which means get it alone. 17 is attached by subtraction. I'll move it by addition to the other side of the equal sign. My x is alone. Final answer is 18. Number 2, x over 2 equals 18. I want to solve for x, which means get it alone. 2 is attached by division. The complement of division, which means to undo it, is multiplication to the other side of the equal sign. X is alone, and it's equal to 2 times 18 is 36. Number 3, x over 2 minus 17 equals 1. This looks like number 1 and number 2 put together. And we're going to undo PEMDAS to solve, which means to get x alone. We start from the end to solve. First, we undo subtraction. 17 is attached by subtraction. I'll move it by addition to the other side of the equal sign. There is nothing attached by addition. There's something attached by division, and that's a 2. I move it by its complement, multiplication, to the other side of the equal sign. I'm done. X is equal to 1 plus 17 is 18 times 2, 36. Number 4, 3x over 5 plus 12 equals 30. I want to solve for x. First, I undo subtraction. There is none. I undo addition, and I do it by subtraction to the other side of the equal sign. Keep your eye on the prize. Don't reduce over here. I see x. 5 is attached by division. 3 is attached by multiplication. First, I undo division by multiplying it to the other side of the equal sign. Now, the 3 is attached by multiplication. I'm going to move it by division to the other side of the equal sign. X is alone. That means I've solved. I'm going to do this arithmetic. 30 minus 12. I borrow 1 here. 10 minus 2 is 8. That left 2. 2 minus 1 is 1. So I have 18 times 5 over 3. I'm going to take that 18 and make it 3 times 6. I chose 3 times 6 instead of 2 times 9 because I saw a 3 on the bottom, and 3 over 3 reduces to 1. So I get 6 times 5 is 30. Number 5, 3x over 5 minus 12 equals 30. It's almost like the last one, except I'm subtracting 12 instead of adding on this side. How do I undo subtraction? I add it to the other side of the equal sign. Keep your eye on the prize. I want to get x alone. 5 is attached by division, so I will multiply it to this side. 3 is attached by multiplication, so divide it to the other side. X is alone. Now I'm just going to do the arithmetic. 30 plus 12 is 42. Now, since 4 plus 2 is 6, I know this is a multiple of 3, and I do a whole playlist on numbers if you want to take a look at that to make your reducing a lot faster. So I'm going to go with 6 times 7 here. Then I'm going to take that 6 and make that 3 times 2. The 3 over 3 go away, really reduce to 1. And I have 2 times 7 times 5. 2 times 5 is 10, times 7 is 70. Number 6, 3/4 equals 1/4 plus 2x over 3. 1/4 is attached by addition. I'm going to move it by subtraction to the other side of the equal sign and move that equals over there. Okay, now the 3 is attached by division. I'm going to move it by multiplication. And the 2 is attached by multiplication. I'm going to move it by division. And am I rolling through this fast? I am. I keep on just taking everything away from the x. Now I'll come over and do my math because my x is alone. But yeah, I do roll through them so that I can keep going towards the goal of getting x alone. So 3/4 minus 1/4 is 2/4. I'm going to rewrite it down here. 3 times 2/4 over 2. Well, 2/4 is 1/2, so I'm going to just do this, okay? So now 3 times 1/2, I put the 3 over 1 and I multiply tops. 3 times 1 is 3. 1 times 2 is 2, all over 2. This is called a complex fraction. So I'm going to write it again, and I'm only doing this so that you can see it better, because if I were on my own, I'd be fitting it in here so that I don't make a transcribing error. I put this over 1, flip the bottom over, put it at the top. That undoes the division. And then with multiplication of fractions, you multiply the tops. 3 times 1 is 3. 2 times 2 is 4. Number 7, 5x minus 1 equals 1/4. I want to get x alone. I'm going to go for this subtraction first and add it to the other side of the equal sign. Now, 5 is attached by multiplication. Move it by division to the other side of the equal sign. I have x alone. Now I'm going to do this math. 1/4 plus 1. I'm going to make this 1 into 4 over 4 because I'm going for the common denominator here. Now that the denominator is both 4, I can write it once and add 1 plus 4 is 5. And this is all over 5. I'm going to write the 5 over 1 so I can flip it over and put it at the top. That undoes this division and turns it into a multiplication problem. Hey, wait, 5 over 5 reduces to 1. My final answer is 1/4. 1/4. Number 8, 29 equals 13x over 15 plus 3. I want to get x alone, and there's 3 attached by addition, 15 by division, 13 by multiplication. And according to PEMDAS, we undo subtraction, there is none. We undo addition, that's the 3. I'll minus it to the other side of the equal sign. Next, we undo division, that's the 15. I'll bring it right up here by multiplication. And then the 13 is attached by multiplication. I'll move it by division. My x is alone, so I'm done. Now I'll reduce this. 29 minus 3 is 26. And right away I see this 13 here. So this 26, I'm going to make it into 13 times 2. If you recognize it, reduce it. 13 over 13 is 1. I end up with just 2 times 15. That's all that's left of all this, okay? And I get 30. Solving 6b, review 2. We're solving linear equations with lots of fractions, so grab a pencil and paper and follow along with me. Number 1, x minus 32 equals 1. I want to get x alone. 32 is attached by subtraction. Move it by addition to the other side of the equal sign. X equals 33. Number 2, 2x over 3 equals 33. There's nothing attached by addition to x. There's nothing attached by subtraction. Division. I undo division by multiplying to the other side of the equal sign. Get rid of that division sign because I turned it into multiply on the other side. 2 is attached by multiplication. Move it by division. I always look to reduce, but this isn't even, this isn't even. 2 isn't going to go into any of these. So I can just multiply out. 33 times 3 is 99. Over 2. Number 3, 2x over 3 minus 32 equals 1. I want to solve for x. 32 is attached by subtraction. I'll move it by addition to the other side of the equal sign. 3 is attached by division. I'll move it by multiplication to the other side of the equal sign. Okay, my x is alone. 1 plus 32 is 33. 2 isn't going to go into anything here because these are both odd, and I'm getting 99 over 2. Number 4, 7x over 8 plus 8 equals 50. 8's attached by addition, move it by subtraction to the other side of the equal sign. Now this 8's attached by division, move it by multiplication to the other side of the equal sign, it's gone. And this 7's attached by multiplication, move it by its complement of division. X is alone. I'll just clean this up. 50 minus 8 is 42. And I know 7 doesn't go into 8, but 42, I could write as 7 times 6. 7 over 7 reduce, and I get 6 times 8 is 48. Number 5, 5x over 6 minus 8 equals 92. I want to solve for x. 8's attached by subtraction, I'll move it first. 6 is attached by division, I'll move that next by multiplication. 5's attached by multiplication, I move that finally by division to get the x alone. Now I'll see if there's anything I can reduce. 92 plus 8 is 100, and I know, okay, so 100 I can write 10 times 10, because that's the first thing that came into my head. I'll take just this 10 and write it as 5 times 2. This 5 and this 5 reduce to 1, and I end up with 10 times 2, which is 20, times 6, which is 120. When you're reducing, it's nice to know it's in the bottom so you have a goal, but if you at least start factoring it down to smaller and smaller factors, eventually something matches up. Number 6, 5/7 equals 1/7 plus 2x over 7. This 1/7 is attached by addition. I'll move it by subtraction to the other side of the equal sign. The 7's attached by division, move it by multiplication, and I'll rewrite that equal sign. Now the 2's attached by multiplication, move it by division to the other side of the equal sign. And I'm getting x equals 5/7 minus 1/7 is, I'm going to write it down here, 4/7 times 7 over 2. 7 times 4/7, I can put a 1 here, and this 7 and this 7 are going to reduce away. So I have 4 over 1, which is just 4 over 2. 4 over 2 is 2. 2 equals x. Went from looking pretty ugly to a nice, neat answer. Number 7, 14x plus 1/3 equals 3/5. I've got to get x alone. 1/3 is attached by addition. Move it by subtraction to the other side of the equal sign. X is almost alone. It's got 14 attached by multiplication. Move it by division to the other side of the equal sign. My x is alone. That means I'm done, but now I'm going to clean this up. I have 3/5 minus 1/3, so I have to do a common denominator. I'm going to multiply this by 1 in the form of 5 over 5. I'm going to multiply this by 1 in the form of 3 over 3. Notice this form of 1 is with this denominator, and this form is with this one. Okay, I'm going to go this way because I have to be really careful. I always pull my other finger in and point. I was gardening. That's why my hands are dirty. 3 times 3 is 9 over 3 times 5 is 15 minus 1 times 5 is 5 over 3 times 5 is 15. Still all over 14. Now, these are the same denominator, so I can draw the bar long, put the minus here, and only look at the 15 once. Now, 9 minus 5 is 4 over 15, all over 14. Now I have a complex fraction. I'm going to put a 1 here, flip the bottom over, and put it at the top. Okay, not a lot to reduce here, except this is even and this is even. So I'm going to write this as 2 times 2, and this is 2 times 7. The 2 over the 2 reduced to 1, and I get 2 over, I have to do 7 times 15. 7 times 5 is 35, put up the 3. 7 times 1 is 7, 8, 9, 10, 105. And I know that's not going to reduce more because when it was in pieces, I reduced it as far as I could. Number 8, 21 equals 5x over 9 minus 4. I want to get x alone. 4 is attached by subtraction. Move it by addition to the other side of the equal sign. Now there's something attached by division and multiplication. We undo division first, and it's a 9. So there you go. 5's attached by multiplication. Move it by division to the other side of the equal sign. So let's see if we can read what I wrote here. I'm going to write it again, which I don't usually do, but I'm going to. 21 plus 4 is 25 over 5 equals x. 25 I can write as 5 times 5. This 5 and this 5 reduce to 1, and I just end up with 9 times 5 is 45 equals x. Congratulations on getting through that solving with lots of fractions.